Our project is called Air Watcher Drone. So Air Watcher Drone is the pollution monitoring UAV or unmanned aerial vehicle. Our motto is to watch the air and help save around 4.2 million people who dies of air pollution every year. So this is part of the final project for DGMD S17 robotics, autonomous vehicles, drones, and AI course for the Harvard Summer School. So what we are going to showcase today is how this project combines several technologies such as IoT using the AtmoTube, the drone and ROS, the robotic operating system, analytics, blockchain, and AI. So our team consists of myself, Romeo Sikihor, Arturo Gamboa, and Eric Sun. So our motivation. So there's about 4.2 million people who dies of air pollution according to WHO every year. In fact, 92% of children globally live in air polluted areas, and air pollution causes asthma, neurodevelopmental disorders, childhood cancers, and even infant mortality. So we thought of building a drone that can detect volatile organic compounds in the air. VOCs have been listed as known carcinogens, irritants, and toxicants that can contribute to asthma and other pulmonary diseases, lung cancer, and even death. So it also detects the bigger version of the AtmoTube, which is called the AtmoTube Pro, to detect particulate matters 1, 2.5, and 10. PM1 are pretty much are viruses, and then PM 2.5 are combustion particles and organic compounds like metals. Then PM10, these are your typical allergens like dust, pollens, and molds. And our idea is to detect all this, with a bigger version of the AtmoTube. So the technology stack. So we're going to be using the Tello Edu DJI drone using Python and OpenCV, the AtmoTube Pro and AtmoTube Plus, and the Planetwatch blockchain using Algorand that sends all the information back to CERN, which is the largest physics laboratory trying to help build air quality for the world. Our goals is to reach autonomy level 3, and so our main deliverables would include development of a computer vision AI smoke fire detector. Of course, the expected output is to detect industrial residential chimney smokes, smoke belching cars, and for smokers or vapors. The second one is to have an autonomous flight and target tracking with PID controls. So this is going to launch the drone and track and hovers the UAV using a PID control at a safe distance and altitude to capture air samples. And the third one is to send air quality to Planetwatch blockchain. So air points of interest mapping information sent via Algorand network blockchain and Planetwatch blockchain into the CERN's C21 project. As a bonus, we are also going to show you the Air Watcher's object detection functionality. This is using SSD or single site detection, deep neural network, and COCO or common objects in context model. So what are the core features we want to achieve? As I've said, so first is the smoke fire detection using computer vision algorithm. So detecting the smoke or fire from chimneys, motor vehicles, smokers, and vapors using HAAR cascade model. And the second one is the target tracking with PID support to hover and adjust speed and distance according to target's distance and altitude. So as a quick application diagram, so what we intend to do is make the drone take off and then turns on the camera and using the OPENCV code, so it will start detecting the smoke. And if it detects a smoke, then it will fly over and hover the target. And that's where the air sampling is going to happen. So the smoke detection pipeline, again, we are going to be using HAAR Cascade GUI trainer. So that is a tool that we found in Windows, and we trained 130 positive smoke images like chimneys, cars, and smokers, and another 130 negative sample images from cable. So originally it was more than 3,200 images, but the training was so slow, so we kind of downgraded to 130, which makes more sense. And the step 2 and 3 is the safe autonomous air sampling pipeline. And here we want to have the DJI Telodrone to fly over the target and and start recording air samples. So again, for this testing, we are using ROS emulation using the Telo SDK3, OpenCV, and HAAR Cascade for object detection and tracking, PID control using video feed coming from the Telodrone. And of course, the blockchain part, we use this Algorand blockchain for decentralized data transmission. And then we are sending everything through Planetwatch Air Quality Blockchain Ledger to CERN's C2MON project. So next is the demo portion. So what we are going to demo is first the smoke and fire detection using computer vision and AI. And then we are going to fly and hover a target at a safe distance and altitude using PID control. And next is the live quality analytics of vaping and alcoholic drinks using AtmoTube IoT sensor and the Planetwatch blockchain. And again, as what we've said, so for the bonus, we are going to also show you the object detection functionality of the AirWatch. So the demo one includes the OpenCV and HAAR Cascade smoke detection. So again, using HAAR Cascade, this is arguably the OpenCV's most popular object detection algorithm. So we trained our smoke detection model with positive smoke and negative smoke. We used a GUI trainer for Windows, 130 positive data sets and 130 negative data sets. And for this demo, we are going to just show you our first intent in our pipeline using the laptop webcam to test the program prior to migrating it to the Telodrone. So let's get it on. All right, so for our first video demonstration, we are going to show you our pipeline on how we build our smoke and fire classifier using OpenCV and HAAR Cascade. So we trained about 130 positive images of industrial chimneys and residential chimneys, car smoke, and just regular people smoking or vaping. And also I added pictures coming from a makeshift chimney that I built in my backyard to test the model that I'm going to show you in a little while. So after building the model using a GUI, trainer, a HAAR Cascade classifier, so we now have what we call the smoke.xml file. So this is the output of the training that we did for both the positive and the negative images. So we're going to run this program, and I'm going to show you the image of a fire and a smoke in my grill, and also try to run a video clip of the same makeshift chimney that I built. So let's try the first one. So let's see if it's running. Okay, so as you can see here, this is a single image or picture. As you can see, the model is classifying it properly, and you can see it down below that it's detecting a potential air polluted. So that's just a single image classification. And now we also have a video clip here. So let me see if we can detect it as well. There you go. So it's classifying the air pollutant. And so that is the first stage in our pipeline for the air watcher. And the only thing we need to do is stitch it up into the Telodrone. Thank you. So in our next demo, we are going to show you the autonomous flight hover and target tracking. So again, with the DJI Tello and CV Zone, Python, and OpenCV libraries, the AirWatcher drone will fly autonomously to a target, a smoke or a smoker at a safe distance and altitude. So if it's a moving target, like a smoking person, then it will follow and track the target using PID control. So now we are going to demonstrate the PID control using Python and the DJI Tello library. And it's going to detect the target, smoking, and as you can see here, it's tracking the face and it's following the target. All right, so this is now the AtmoTube Plus. So I broke it, so the Tello drone doesn't have problem carrying it and flying. So as you can see right now, the air quality here is pretty good. And then I'll build my makeshift chimney with VOCs. So that will be acetone and some charcoal lighter fluid. So inside I have some um, coal and I'm going to light it up to simulate. Now I generated the artificial chimney smoke, and as you can see, the drone is hovering at the safe distance. So now let's watch how it's reacting. See, now it went to a critical air quality score. So for demo 3, we are going to show you the live air capture and streaming to Planetwatch. So again, while the AirWatcher UAV hovers over a target, it will capture air quality samples every 2.5 minutes. So there, again, we want to capture the air samples online. So the AtmoTube uses BLE Bluetooth to communicate to a smartphone or tablet to transmit data to the blockchain using internet protocol. But again, since BLE has limited range, so most of the time you will be offline. So you can also do offline air sampling, and then you can send the data to the blockchain once you get back online. So here is the demo. All right, so this is demo 3, and we want to show you the blockchain part of AirWatcher UAV. So this is the AtmoTube Plus. This is what we used in our demo, since the bigger version of the AtmoTube, which is the AtmoTube Pro, cannot be carried by the Tello drone. Unfortunately, this small one doesn't have the blockchain features with Planetwatch, but again, it's light that the Teletron can carry it. No? So for this demo, I'm going to show you that I'm going to vape, and let's see live how the AtmoTube can sense the PM1 or PM2.5 or PM10 or VOC, depending on the air pollutants that it will detect in the air. So PM1s are naturally, typically they are viruses. PM2.5 are usually combustions and organic compounds, and PM10s are your typical allergens, so like dust, pollens, and molds. And so I'll start with the demo using a vape. So I'm going to vape over the sensors, and let's see how they would react. So as you can see, the air quality even went really bad, right? From 89 up to 0. So we'll see it will normalize as the air quality improves in the room. And after that, we are going to do the next test, which is the VOC. So for the VOCs, I'm going to try to use a very simple test with a liquor. So this liquor is only 31% alcohol, but if I try, to put it close enough to the sensors, you can see that the VOC contents of this liquor is high enough to be worried about. So you saw that? So the VOC went up to 8.28. So, and that's what we drink, right? But anyway, after this project, I think I deserve this one. Thank you. So for demo 4, we want to show you air watcher live object detection. So again, as we said, we use ZB Zone package and use the following models: SSD, or the single site detection. It uses small convolutional filter to predict object categories. Filters are used to extract feature maps to perform detection, resulting in high accuracy, even in low resolution images. And we also use COCO datasets. So COCO is Common Objects in Context. It provides supervised computer vision datasets that enables the identification of common items. So let's see. All right, for this last video, we are going to demonstrate to you object detection AI in the Tello zone. So this is using SSD, or single site detection deep neural network model, and COCO pre-trained dataset. So as you can see here, it's actually detecting objects around. So you can see a chair, person, and pot, and everything. And so this is our final video, and thank you for watching. In conclusion, computer vision AI, in our project, we used OPENCV and HAAR cascade method. We can obtain high computer vision detection accuracy of smokes, fires, faces, and objects. But as a prerequisite, there you need to have good sources of images, and of course, training and patience is also required. In terms of the drone UAV programming, so we use the DJI Tello library STK3. It also requires very specific version of Python interpreter, and specifically 3.7.6 and OpenCV 4.4.0.44 for all the components to work properly, emulating a ROS environment. So for PID control, it is required to make target tracking possible, to make the UAV hover at a safe distance and at an altitude. In terms of IoT sensing and blockchain, so the ATMO2 Plus, as we said, does not have the Planetwatch blockchain support, but for demo purposes for the class, that's what we used, because the Tello cannot carry the ATMO2, and in fact, I had to break the ATMO2 Plus to make it even lighter. So in future, we are going to use larger drones and mount the bigger ATMO2 Pro on it. For the object detection model, so again, we used a single shot multi-box detector using MobileNet version 3 and pre-trained COCO, or Common Object in Context datasets. And that's how we made the Air Watcher drone to identify common objects in front of it. And finally, vapes and alcoholic drinks are both air pollutants and harmful to health. And I guess we all know this, but we just want to prove it as our main point for this project. Issues encountered. We first have issues with the simulator. We were not successful in making the gazebo to work properly. We tried on Windows 10 with VMware, Raspbian with a Raspberry Pi, Ubuntu, 16, 18, and 20 on AWS, but none work to our satisfaction, especially looking for compatibility with the DJI Tello drone. We also had overfitting. The first HAAR Cascade model had overfitting problem. We had to retrain the smoke classifier model and also to lessen the number of images, negative images, to make it lighter. The Telodrone SDK compatibility issues. The SDK 3 requires very specific Python interpreter, as I mentioned, 3.7.6 and OpenCV 4.4.0.44, and specific libraries and packages such as NumPy, CVZone, and other things. We also lack the drone programming experience. So I personally had to take additional workshop courses on basic drone programming and advanced drone programming from CVZone. The